Oh boy. Oh boy. Good old pretzel is not working today. But hopefully our levels are good. Get that popping in a moment. Welcome, welcome everybody. Uh, my name's Agent Ultra. I'm here to program today in Haskell, as I do once a week, usually on this stream. Build stuff, practical things, sometimes not so practical things. And this week, I put up a little poll on the old socials, and it looks like we are going to be working on the Tigerbeetle client I started last week. So, all right, awesome. Let's get those tunage going here. Just a moment. Get everything set up. Prepare. Almost there. There we go. Super. Okay, yeah. So Tigerbeetle, if you don't know, is a financial transaction database. Kind of specialized. It's a database specialized to financial transactions. So creating accounts and ledgers of those accounts and transactions and transfers between those accounts and things like that. It's also, I don't know, meant to be super fast for some reason. It's probably pretty good for high volume stuff. I kind of work in this space, so I've been watching this project for a while and kind of want to play around with it, learn more about it and how it works, that kind of stuff. And I primarily do stuff in Haskell, so I figured I'd write a Haskell client in order to help myself learn about Tigerbeetle and to provide benefit to the community by having a client for this database written in Haskell. So that's all about that. Basically we have to do some FFI type stuff in order to get this going. So yeah, we're gonna do that. And yeah, okay. I'm just gonna make sure chat's all up. I'm kind of like half prepared this week. Pew. Okay, got chat, got activity feed. We're good. Okay, let's get to the code. Okay, so Tigerbeetle database. We ran into some issues last week on the stream on Friday where the bindings generator I was using, or trying to use and learn about how to use, that kind of stuff, C2HS, doesn't parse the 128-bit uint, unsigned 128-bit uint type. It doesn't parse this, uint to 128 T. That's because I believe I created some issues in the community and like reached out to people over the weekend and tried to figure this out. As far as I can tell, this is not defined by the C standard. This is like a compiler extension implemented by like say GCC to implement this type. So pretty sure what we're going to have to do to work around this is to write a C wrapper around the Tigerbeetle FFI API, which not super awesome, but not the worst. I did reach out to the project there to like ask around, like, is this 128-bit thing like cool, like, how other clients are doing it, because like seems to be a little bit non-standard, but yeah, but I think they're going to stick with 128-bit T. I'm not going to expect them to change their project just for that, just to make writing FFIs easier. I think the general gist of it though is that like a lot of other projects are writing their own marshalling code for it, and I think the tack I need to take with this is to write our own marshalling code for it. The problem with this though, no matter how we approach it, whether we like use a binding generator, we write the bindings by hand. Haskell's FFI can't marshal 128-bit types natively, or like user-defined like non-primitive types. That's for reasons, is because like the Haskell compiler will actually generate the code that like goes like the native code, the you know, the C code. I don't know how to put it. But it'll generate the code directly. That'll go like that'll interoperate with C, so it doesn't like generate that kind of stuff directly. However, there might be a way still to do this. So yeah, I'm learning a whole bunch of stuff right now about all this stuff. Okay, first, so when you look up foreign function interface stuff, or like how to wrap stuff in C, in Python, or in Haskell, you're gonna run into like the classic stuff, the forward function interface, language extension, FFI, that sort of thing. There's another extension for writing C stuff that's newer. I think it's called C API. C API FFI is the way to do it. So this is going to be one part of it. We're going to have to write all this stuff out by hand, since our generator isn't really going to do it for us at the moment. And the other thing we have to do, I think, is that we're going to have to write some wrapper C code for this, for anything that passes this 128-bit unsigned integer by value, or if we oftentimes we use these structs in the Tigerbeetle API that also have 128-bit fields, and we're gonna have to like parse those and pass them into Haskell, which is gonna be super fun. Yeah. So unfortunately, it's not a huge API, so there's that at least. But let's bring up the code. Clients, C, tbclient.h. All right, so this is what we can't parse with our bindings generator. This type is used freaking everywhere, and like all the structs use it, I think. uint 128t. Boom. Hey Goku, what's up? Welcome back to the stream. Thanks for coming by and stopping by. Yeah, you can see it's used in this struct, it's used in this struct, it's used in this one, this one. It's passed by value here as a cluster ID to tbclient init and to echo. So not too bad, but we're gonna have to basically, anywhere like we return this, we're gonna have to like figure out how to deal with that, because we can't support these directly in Haskell. We have a word 128 type from the wide word library that we can totally pass values into, but these gonna have to pass by pointer, which is gonna be super fun. So we're gonna write wrappers for those, and yeah. So that's kind of like the big stumbling block here that I gotta figure out. So let's see, where should we put this? Not in that area though. Probably an include. Maybe we'll call it tbclient shim.h. And we'll probably need a C implementation for these things, because we're going to be basically implementing all this stuff, wrapping all this stuff. TB status is fortunately just an enum. That should be pretty straightforward, but we're going to have to wrap this whole signature and provide our own implementation for this. And this bad boy. I'll call it H. I'll prefix something with HS. Okay, we're gonna need a couple of imports here. Some includes. I think std_int. We're gonna need a TB client. And yeah, this is gonna have to be passed by pointer. Everything else I think is fine. TB client T, Tiger T, uint 8T, those are all fine. Okay, let's just work on this one. Yeah, like that. That's fine. Whatever. Not super important where that goes. Okay. Okay. So now we're going to need an implementation for this. That's going to be TB status. TB client shim. And TB client. I'll do TB client net. And then all this. Pop, 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 pop. That though. That's a really long thing, but yep. Okay. So all this wrapper has to do is deref the pointer of the cluster ID when we pass in the argument to all the arguments into the regular TB client init call. We might have to do our own type def for our own actual uint 128T thing. For the Haskell side of things, because that's actually like a record with two word 64s in it, a high and a low. And this should work as long as the 128s here encoded by GCC are, like, we encode them the same way. So hopefully they don't decide to flip things around on us. And high just means we'll just use that'll be the most significant part, and the least significant part will be the low. We'll just put them together into a 128-bit T type here and do all that stuff. So let's just not do anything here yet. And I don't want to like write all this stuff yet. I just want to get it to compile and make sure the tooling works. So let's grab a value out of TB client for one of the TB statuses. That seems fine. I might get build warnings that like we're not using any of these arguments depending on how they configure GCC here and Inkaball and all that junk, but we'll see. I gotta get my development environment. Bam. Okay, back on the Haskell side. Let's go to Cabal. So we have to like include all our extra source files that we need. That need to be distributed with the package. I think this is a list. Actually, we don't need the rest of that. And don't know if we need to include the C file, actually. If that gets compiled, we just need the header file. Don't know that we'll need that. Well, no, but include here. That's where the shim is. I'm probably gonna have to look up stuff in the manual, but I'm just gonna try building that, just see what happens. Okay, that's probably from... Okay, I have a little bit of code in there already. Okay, oh, I got some foreign data code, wrapper code in there. What do I got here? Yeah, no. No, we don't need that. Let's get rid of that. Rid of that. I'm actually, this source tree is probably a little out of date, so I'm just going to stash that. Fetch. Yeah, so I removed the bindings. Oh, that issue from last week's coming back. I can't use Git properly here, Magit properly here anymore. Okay. Stashes. Apply that one again. Okay. Start building now. Okay, there we go. Failed. Try clean. Source, database. Should just be that file, nothing else. How does it know about this? Still, I cleaned the build. Oh, I probably left it in the Cabal file. No, just database.tigerbeetle. Oh, there it is. Slimmy. Yeah, this probably hasn't compiled any of the C code into our library code here. Probably. Anyways, with Haskell stuff, I think this is like the recommended API now. C API FFI rather than the gold forward and function interface API, which is still there. There's like a lot of code uses it, but I think this is the one you're supposed to be using now. So it's good to know. It's not too different. They're fairly similar. I think the major difference, I guess, is this stuff that I'm highlighting. So it also imports values rather than just functions. And some other things because it compiles out to C first, I guess is the idea. Now, that's about that. I think maybe you gotta look it up in the Cabal manual. How to we just gotta link it. File and link it. Come on, come on. Oh, why the heck is this so slow tonight? What's going on? Okay, here we go. System dependent parameters, all that sort of stuff. Install include list of header file names and package to be installed when the package is installed. Okay. Files listed in. Well, that's really annoying highlighting, but when the package is installed, files listed in install includes should be found in relative to the top of the source tree or relative to one of the directories listed and include dirs. Install includes is typically used to name header files that contain prototypes for foreign imports used in Haskell code in this package, for which the C implementations are also provided with the package. Example, here's a Cabal file for a hypothetical binding CLib package that bundles the C source code for CLib. There we go. Okay, so include dirs, C sources goes there, install includes the headers. Okay, and now any package that depends directly or transitively on it can use clib.h. Cool. Sounds good. What is this song? I don't know if I'm down with this. Gotta change up the music here. Okay, that's better. Okie dokie. Okay, so that's what we need to do. Let's do that. Include dirs, good. Install includes, okay. That's for what's when we install the package, what will be put into the user's include paths. And that will be tm client.h and tm client shim.h. Yeah, I don't know if we can make the Cabal package install Tigerbeetle for you. But, yeah. Yeah, you're gonna need it at some point. Okay, and then C libraries go in C sources. Okay, good to know. And that will be td client shim.c. Okay. Will this build now? Ah, okay. Does not exist. tb client shim.c. That is in the include thing path. Yeah, we gotta give it a full path here. Include slash. Okay. It's compiled. Alright. That doesn't mean it's done anything useful. It's just it worked. Okay, so I want to make sure that's like worked. What if can we do like a minimal implementation of our FFI module that we're going to write? Okay, we'll see if we can do like a minimal binding module, get it all compiled, and that will be our kind of unit, our base, our starting point. What is going on? Why is it going back to picking music here? This is not my style here. I mean, it's fine music and all, but... Sheesh. Stay with the program, Pretzel. Okay, sorry, distracted. It's because, like, one of my productivity hacks that works for me is, like, I only listen to a particular style of music when I'm programming. I don't listen to this like, the stuff that I listen on the stream, kind of in that vein, in that style. I don't normally listen to that kind of stuff, music, in my real life, my day-to-day life. And, so when I hear it, I'm like, instantly, boom, okay, let's hack. That's kind of how it goes. So when it's switching over to, like, finger-picking music, I'm like, what the hell's going on here? Really weird. Anyway, that was random, but there you go. FFI. Okay. So we have to use this language extension C API FFI. That's the one to use. Okay, and so in our C module, our shim, which is what we're going to be wrapping, which is going to wrap the other library, we got to write a function signature for this. Which is why I think we might need to define our own type def here. for this type at the pointer. Maybe? Let's see. This would be foreign. C API is the syntax. Foreign import C call. Oh no. C API. So header.h f. And then we give it a name and a type. Okay. And so that'll oh, okay. So all the arguments, yeah, so all the arguments to F that get generated by the FFI language extension here have to be marshallable types that the FFI interface knows about. So this is where the problem of the 128-bit type thing comes in, is that the base package doesn't define C uint 128. Right? That comes from our package, the user-defined types. That will be not marshallable. Can't marshal that. So what we're doing is we're going to be passing a pointer to the word thing, the word 128 data structure that we have in Haskell, and pass that into this shim function, and then the shim function is going to have to basically unpack that into the 128 proper, and then call the actual code. So hopefully it's probably not gonna be like too much overhead, but yeah. The price we pay. The price we must pay. So I don't know. I don't know. If I was writing an interface for my database, I don't own Tigerbeetle, so it's not a thing on dig on Tigerbeetle, but I'm just saying, like, if I was writing my own, I'd probably write it to make sure that it was just plain standard C. Not using any extension types like this, maybe. Or I would probably set the type def to like a structure that is composable, so that it's easier to write for foreign function interface code for this stuff. To my stuff, basically. Anyway, foreign import C API, and then we're doing hs underscore tb underscore client init. In tb, I got the h file comes first. tb client shim.h. And just so that we know it looks like FFI code on the Haskell side, if we import this anywhere, I'm going to kind of use the same snake case here. I think that should work fine. And then I gotta give the whole dang type. I don't know, format this so I don't like just do it on one line. Can I do it like this? Okay. So we have TB client T out client. Pointer to that. So we're going to need some imports here. I'm going to use the data decals. Yeah, we got import foreign pointer. And then we have to define data TB client. Okay. Yeah, really doesn't like the way I'm trying to format this. Okay, so then we got a pointer to word 128. going to come from wide word 128. And then we have 30 seconds for an aceta string. We get C string. And then we have U and 32T, so we need C, I think it's types. C uint 32. And then we have an unsigned uint pointer T, which I think is uint pointer PTR. And a callback. I'll leave that for a second. That's a big old callback. And then we return a TB status. Which we'll have to define. Well, I think we can actually just return that pure. Assuming, of course, that this, well, this, it actually does do IO, so it should be in IO. So it does side effects on the C side, right? It's going to be calling into the Tigerbeetle code, and it's probably going to be starting up some threads there, or a thread, and doing stuff, and passing us data back and forth. So that's side effecty, that's IO-y stuff. Okay, so this callback type. Maybe do it like a type alias for it. On completion. That is going to be another unsigned pointer. A TB client T, whatever that is. Ooh. We might also need to wrap that callback, depending on what's in that struct. Pointer TB packet. Pointer to a C uint. A C. I think it says just a C char. And C uint 32. And we return void pointer. That gets passed in here. Okay. Does it build? Oh, right. We're not. This module isn't being linked anywhere or imported anywhere, so it's not getting picked up. What if we just import it here? Don't do anything with it for now. Okay, cool. So we have some type errors, of course. Alright, or not C type, C uint. That's probably it. Yes, the foreign modules that are in base for these C types are the naming mnemonic. I think is based off of like the unqualified type unqualified size types in C, which not my favorite. So, for example, CU in pointer, there's wraps word 64, but like C int max is fine actually, but like, where's one example? CU long, L long. So like, generally in C code these days, we don't write unsigned long. Right? We write what it is. And that's what the standard in library is for, but yeah. So anyways, the mnemonics are built off of those. So C longs are 64s and CU ints are word 32. So yeah, the suggestion was right. So I'm just gonna do that. Replace. Okay. Try that. Okay. We know TB status isn't, TB packet isn't. Okay, cool. All right. So we got some things we need to define. TB status. Simple enough. TB status success. I think I'm just going to grab all of these and just macro this out. Okay. I'll go forward white. Forward white. Okay. No. Not what I wanted. Capitalize word. There we go. How am I gonna... Yeah. Maybe I can do it with region. That's not the macro I wanted. Okay, let's try it again. Forward, white space. Go to the end of the line. Capitalize region. Pretty good. Alright, we're going to delete all of that. We're going to replace string and region with nothing. And then we go to the beginning of the line, down, finish, do. Done. Oh, except I gotta put in these. And that. And that. And there. Okay. Okay, we can derive a few basic things for that. EQ show. We're gonna need enum. Since 0, 1, 2, 3, 4, 5, 6, I think we should be able to derive enum for this one. Some of the other ones where they have non-consecutive, we'd have to like define our own. And from the code generator that we did use the code generator for the enums, which maybe I should bring back in to at least use it for that. But it had to write, was able to pick these up and actually write like the correct enum instances for them, where they are using like custom numbers like this, or like these. Anyways, we're going to define them by hand though. Just to get this going here. And what else? So we got that one going. Hopefully that error goes away. Cool. So I think the reason why that kind of does sort of work for this, hopefully continues to be true, and I'm not like wrong here about this, but I think the reason why this works and is marshallable, even though we defined this type ourselves, is because of the enum class. So Haskell knows how to translate those into the integer representations, which is the same thing on the C side. The C side just knows them as integers. So they can be passed around kind of similarly there that way. Boop, chat. Another band that we have to go. Bye-bye. Okie dokie. Alright, sorry chat, I haven't been ignoring anybody, but let me know if you have any questions or anything like that. Happy to take little diversions. Backseat programming is also cool too. Okay. So anyways, I think that's why that'll work. It'll be marshallable because of the enum class, and the FFI knows about that. We just have to figure out TB packet. Okay. Do we have any 128s in here yet? We don't. Oh, thank goodness. This should be pretty straightforward to marshal, this one, yeah. I think we can just write this as a record. Think. And yeah, how to get fields out of it and data out of it when we get one of these, or have to pass one of these around. I'm not super keen on that one yet. Good to pass these in. Packet. No, we get, this is in the callback, okay. We get a pointer to one of these. Yeah, so on the Haskell side, I guess we'll have to figure out how to get the data through that pointer when we define our callbacks. And marshal that into Haskell record. Okay, so we have TB packet. Back over that struct definition. Next, we have pointer to TB packet. We've got TB packet user data. That's a void star. So I'm just gonna put that like that and create another empty data declaration for it. Just so we don't mix up that void star with other void starry things on the Haskell side. And we have TCP packet operation, which is a CUint cchar. Packet status, also a cchar. Packet data size, which is a CUint. Data. It's going to be a point, another void star pointer. I will call it TB packet beta. And let's see, TB packet batch next. TB packet batch tail. So I guess this struct here is carrying the data from that for our query from the database to us. TB packet batch size, CUint, and TB packet reserved. That's going to be an array. There are ways to define that as well in Haskell. Or in array. Or not marshaled array. Cool. So let's do that. Yeah. Or in marshall.array. And it's essentially going to be... Oh, okay, these are all the functions to initialize them, but it's just pointers. Okay. So then we don't need that yet. So it's going to be pointer to cchars. Funny that it can't define the type of the array, like with the size and everything in Haskell. That'd be pretty cool if there was a way to do that. Wonder if a good practice might be to like comment that. Could get out of date. I mean, you're gonna have to look at the header, I guess, to know that. Okay, well, that defines the packet, the data packet. And maybe this will build. Not quite. Okay, unacceptable argument type in foreign declaration. Okay. Something cannot be marshaled here. Oh, yeah, I guess TV client probably can't be. Yeah, so we're gonna have to probably also wrap the type with the callback. I think. Oh. I can't marshal a callback? That would put the kibosh on this immediately. Unless there's like a way to specify that I don't know about. Haskell. Marshall callbacks on C. You get fun pointers. Yeah, okay, fun pointer. Haskell. Foreign, let's see it, a pointer. Function pointers. Okay, we do have that. Thank goodness. How do we specify those? Okay. A value of the type fun pointer A is a pointer to a function callable from foreign code. The type A will normally be a foreign type, a function type with 0 or more arguments, where the argument types are marshallable foreign types. Any of these, or a renaming of any of these using new type. Return type is either a marshallable foreign type or as the form IoT, where T is the marshallable foreign type or unit. Value of type fun pointer may be a pointer to a foreign function, either returned by another foreign function or imported with a static address import. Okay. Or a pointer to a Haskell function created using a wrapper stub declared to produce a fun pointer of the correct type. Okay. Calls to wrapper stubs like this one. Allocate storage. Okay. Right, it's going to create a stack frame for the arguments that have to be passed in and all that stuff. So I guess Haskell can compute all of that, which is cool. Which means we have to release the stack frame and all that sort of stuff with free Haskell fun, or whatever it's using to allocate. To convert fun pointer values corresponding Haskell functions, one can define a dynamic step with a specific. Okay, so hopefully I just need to wrap this in a fun pointer and I can pass it in to the type here, because basically I think the header here is asking for us. And Tigerbeetle is asking us to provide a callback to handle the data it sends us. And I guess with it being void star, it's not expecting us to return anything. So we just get the data in this thing. So I think that means this can just be a plain old Haskell function. So I think, yeah, maybe fun pointer would work. So maybe we want to find it like that, and then maybe I might still need the pointer for TB client there, but just here, a fun pointer. It's your the world, you know. You can do whatever the compiler tells you can do. Yeah, okay, so we do need to make that a pointer because TB status cannot be marshaled. Maybe we have to implement another type class in order to make that marshallable. I think that should be possible to be marshaled that, though. Maybe we need a storable instance. I think that's what our code was doing before, at least the generated code from the stub stuff that I had previously removed. So create as an enum instance. That's it. Okay, so I was totally wrong about that. I thought that would make that marshallable. Why wouldn't that be marshallable? Okay, so that doesn't work. Haskell, Marshall, enums. Oh, slide deck. Yeah. That's all C call API stuff too. Nope. Maybe we're a little Haskell as an example. Find the word enum. What is this? Automating binding. Oh, they're using another binding generator, HSC2HS. to automate it. But let's look at how to do it without the automation first. Does it show that? Okay, it defines as a new int for a C type. At least in this library, because I guess they're all made as defines. I don't know the PCRE HS thing. Stack Overflow. Key, instance enum, get key, cint to enum, get key. So we have to find get key and C, I guess, here. Foreign C types, you have something, numeric, floating, other. I guess we could probably marshal it as a cint. As long as we write the wrappers showing that this is actually the status, not just any old cint. Maybe. Well, at least compile. It does. Okay. Getting to compile. Let's just add one small little bit to the C implementation to make sure that we're actually calling the C code. Or well, we do return zeros, so as long as we can make a call to this, we should get back 0 and no errors, and that would be it. Okay, so let's go in the FFI module. Load that up in my REPL, and let's see if we can. I don't actually have Tigerbeetle installed in here yet, but we're not calling it yet, so I think that'll be fine. What have we got here? Okay, yeah. Ugh. This is annoying Nix thing. My inbuilt editor set from, so Emacs, I launched from the Nix environment, I thought, which would make this REPL here should be in the right environment to find all my stuff here. Let me, actually no, maybe I didn't, maybe I didn't. Let me just boot that back up so it has the correct thing. I know there's like an Emacs, because I don't use Nix a whole lot, as you probably might be aware. If you're not, I don't use Nix a whole lot, except at work I use it a lot of time. But I don't know a whole lot about it. It's maintained by another team. I just use it. However, I know that there's like Emacs packages for interacting with it better, which might be nicer because like I'm not a huge terminal person. I've come to like not enjoy terminals. And tend to prefer staying in Emacs as much as possible. And I used to actually like really hate on eShell and was like, why would anybody ever use this? But once I actually learned eShell and like how to use it, man, I don't know why I would go back to a regular terminal. One of those weird things. Okay, so let's try that again. Let's go back to file, load up Haskell here. Good. I'm just gonna make sure to set the variable Haskell process type to football. What is it? Replicable. I think it's called replicable. Now let's load that up. Ah, it's dying on me. I can't find stuff. Okay. So my Haskell mode that Emacs is running is probably not coming from the Nix environment, which completely breaks this, which sucks because I love having an in-editor REPL. But we could probably do it out here. If it'll boot up. I think it's a little bit bigger. Okay. HSTB client init. Oh, we called it client ship. Okay, well, it's defined. It's in our REPL. It's here. Okay, so how do I use pointer to construct pointers? Oh, okay, okay. This is interesting. So when we're trying to access a value of type A through a pointer, the type that we pass in on the Haskell side here, this type will often be an instance of storable, which will provide the marshalling operations. However, this is not essential. You can provide your own operation to access the pointer. Or we could write small functions to get into the C struct. Cool. So that just means we'll have to write an instance of that type class for our like TB packet here, and then we should be able to access it as long as it's through a pointer. We can get a TB packet. Cool. Which is probably why we need to write this shim libraries for all this stuff. Okay. So that's cool. So how do I create a pointer? I don't think you exposed the constructor. Yeah. Yeah, constructor not scope pointer. Okay, right. Or foreign student pointer. That is the one I meant. Did I not mistype it? Oh, I just meant foreign pointer. Yeah. Yeah, so you don't expose your constructor. Yeah. So how do I make a pointer to some value here? So I call him a function. I could just pass in null pointers because we don't actually call the arguments, we use them. Yeah, that's what I can just do. So I'm going to use it as an IO action because it returns IO here. Okay. HSTB client shim, which I'm going to rename in a moment. Okay, null pointer. Null pointer, null pointer. C string. Just do like a new C string. Oh, I'm gonna have to like. Yeah. It's not gonna work because I don't have that in scope. Okay. Foreign.c.string as well. Okay. There we go. HS TB client shim null pointer C string. New C string. Oh, I have to do that. I think it's supposed to be the address, so we'll do that. New C string. Null pointer, add cu int. Cu int of word 32, so it'll just be cu int 0. Cu int pointer. CU int pointer to 64 and to expose the constructor. CU int pointer 0. And then we have our fun pointer. I like that it's called fun pointer. The fun one. You're going to have a lot of fun using it. It's a fun pointer. Again, you don't construct, so we can get a null fun pointer, so we're not going to use it. Null fun pointer. And that's it. Okay. Oh, CU int pointer is not in scope. I thought it was. Constructors. Maybe I just mistyped it. Or, no, you know what it probably is? I probably just didn't import that module. Foreign.c.types. Actually, let me bind that. X is 0. Okay. We called our shim code. It worked. Cool. Awesome. Let's make a commit. This is great. Pop you back down there. Here you go. Okay. Progress. Oh, of course, I can't actually commit anything and oh, that's no good. Alright, add, when applied this, it will add source database, Tigerbeetle, internal, FFI, HS. Sick. Okay, so now we have an FFI module, we have it wrapping our shim code, and we have it calling our C code. So we have Cabal actually compiling our C code and like linking it into our code. So that's pretty cool. All right. Man, okay. We are done with that. Done with that. Okay. We're not done with this, though. We are going to implement. We're going to implement the wrapper for DB HS DB client init. We might need to take care of. We need to take care of the in28 stuff. To implement that. Yes. Yes, we do. Alright, so we're gonna have to implement that. Marshalling unit Word 128. Okay. We're going to have to do that one. Let's see. Time on the stream. We might be able to do it, maybe. I don't have time. Okay. A little bit of Haskell, a little bit of C. A little bit of Haskell, a little bit of C. A little bit of Haskell, a little bit of C. Good times. I just want to make sure that we included the C files. Oops, I don't think we did. And that's probably because it's set to get ignore. Yeah. Because we're generating that include directory. So actually, I'm going to include Tigerbeetle for that. So I forgot to do that. Just yeah. Oh, you're not going to use your nice rebase API. Oh, it's going to be annoying. Git commit. Well, I know that if I restart the VM here, I'll get this error to go away, and then so at the end we'll do the rebasing. Progress, add shim. Okay. So yes. Okie dokie. So, in our implementation, the reason why we have to write this shim is because this argument here in the Tigerbeetle API is passed on this by value on the stack, which we can't do from the Haskell FFI because we can't marshal those values. Because I think the way it kind of works internally, the Haskell's FFI, is that it actually compiles the instructions down to assembler and then links all that stuff together using the C calling conventions. I think the C API language extension actually like creates an intermediate C file that then uses GCC or whatever your local compiler is to compile that. At the end of the day, I think that's why it can't marshal those things and has to like just use the fixed type. So it only works with standard like C ISO C types. So in order for us to work with TBU into 128Ts here, when Haskell calls us, we're actually going to be getting a pointer to a word 128, which has these two fields, I think. Wide word. $128. So it's got a high 64 and the low 64. Yeah. Got a storable. Oh, if it's got a storable. Oh, that just means we can... Just poke. I think storable just means we can read it. But poke makes me think maybe we can write it too. And maybe we don't have to write things in the shim as long as we access it through the pointer. Let me look at storables documentation. The module for a storable provides the most elementary support for marshalling and is part of the language independent portion of the foreign function interface. Okay. Okay, so the memory functions of this class facilitate writing values of primitive types to raw memory, which may have been allocated with the above-mentioned routines. Whatever above-mentioned routines it means. And reading values from blocks of raw memory. The class, therefore, includes support for computing the storage requirements and alignment restrictions of the storable types. Memory addresses are represented as values of type pointer A. Yes, yes, yes. Okay. All marshalling between Haskell and a foreign language ultimately boils down to translating Haskell data structures into the binary representation of a corresponding data structure of the foreign language and vice versa. Yes, it does. That's what marshalling is. To code this marshalling in Haskell, it is necessary to manipulate primitive data types stored in unstructured memory blocks. Okay, additional types, which are standard basic types of Haskell. Okay, so the fixed size types, the fixed word types, and stable pointer, and all types of foreign C types as well as pointer. Okay, so it can only access through this in 64s and stuff. Okay. So the storable instance for what is poke? Poke is write the given value to the given memory location. Alignment restrictions might apply. See peak. Okay, so if we have a poke implementation for the word 128, as long as we go through a pointer A, we should be able to write a 128 here. So we might not actually, like, we'll get a pointer on the C side to the 128 value, but if we can poke this on Haskell side, okay, cool. Let me explain. My brain's kind of jumping ahead here. So in order to call a C function, right, you have to, in the C calling convention is defined by like System 5, you have to like create a stack frame, and then depending on the number of arguments and stuff, the stack frame is like all of this kind of scratch space for all the functions overflowing arguments that don't fit in 6 registers, and for all the temporary variables it uses in the function body, things like that. And Haskell can't marshal anything greater than what we saw here in the class. Like you can only poke word in 64s, stuff like this. But the storable instance, if it's for the word 128 type that we're using for this library, has poke, which means we should be able to write it. Hopefully internally takes care of writing a 128-bit value out somehow, and then we can just dereference the pointer on the C side in our shim and call the code normally. This is one I'm not sure about. We could, I think there's a format specifier in printf for 128-bit numbers. Or is there like a special function for it? Yeah, this 20-bit integers. Yeah, GCC specific. So I guess Tigerbeetle on Windows is probably compiling with MinGW or something then. Well, I guess you can pull out the 64-bit parts. Yeah. Gross. I'm just curious what we get. if we just deref the pointer on the C side in our shim, after we marshal this over, also, how do we create pointers to these? I know how to make a null pointer, but yeah. Okay, why don't we... yeah, I hate I'm not actually gonna commit this code. I'm just gonna use it for testing purposes here in our shim. So, I recommend... Okay, so we'll get our 128-bit number by dereferring the pointer, pass it to print here. And then... so that calls printf for us. Okay. Returns n digits. Yeah, that's no biggie. Okay, so let's take our cluster ID here. And deref that. Here. That's the address. Yeah. Okay. Build. Rebel. Actually, nothing. Alright, I gotta define u in 128t because it's not officially a thing. Let's do this type def. It's not proper. Oh, that comes in types, yeah. Means stud IO. Alright, wrong header. I got it. Non-static declaration. Yes. Been a while. Good. That. Those come from We're defining those. Yes. Okay. Cool. Almost. What else am I missing? Another define. Douche. Okay. So we need foreign C types. A foreign C string. A foreign pointer. And I can call you. Except we don't want null pointer for the second argument, right? Cluster ID. It's the only difference here. How do I make a pointer to my word 128 on the Haskell side? That's all I need to know. Oh, maybe Storable will give it to us. No. Well, can I, so like with poke, I could give it maybe, I can't give it a null pointer because I can't change the type of A. Well, null pointer doesn't determine, it doesn't fix A. Okay, so maybe I can just poke that in. Poke null pointer, and then give our wide word 128 value. Okay. Poke is not in scope, so we need to import foreign pointer still. Or no, marshallable. Foreign not storable. And data.wide word. Word 128. And then we have to add a ditter. Okay. What did we have in here? Okay, so it returned an IO action. Oops. Not what we wanted. Let cluster ID, I'm just going to call it CID. No. Yeah, CID equals null pointer. Poke. CID. CIDP. Poke. CID with 123. It doesn't know what type that's going to be, though. And we got a sick fault. Oh, okay. So maybe I just need a Haskell function that can create it for me. It'll be like, word 128 pointer. That and that. I want to give it a word 128 parameter. Yeah, what we're gonna do here is P. I don't think that's gonna have a type. Pointer to word 8. Or I prefer the type application syntax actually. Let's do that. Pointer word 128. Poke P with word 128 as our parameter, and then we return P. And then we import foreign live like a type. Oh, must be near the end of the stream. It's adorable. What's the problem here? So I meant to enable type applications. Okay. Okay. I got a way of making them. Oh, did I get the arguments around the wrong way? Pointer to A, value A, IO unit. That's wrong with this. That's not right. Right, that's wrong. Want a pointer to word 128 returned, but we got an IO unit because poke returns unit. If I try to return pure P, we get pointer to word 128. Oh, that's why. Haha, my type annotation sucks. I just need... Type application here should be fixing A, but I'm fixing A to be pointer, word 28, so I'm actually getting a pointer. Just needs to be... There we go. So smart am I. Okay, so my CID should now be make word 128 pointer. And the word 128 of the day will be 234. Ah, but we seg faulted. Which is not how you're supposed to do it. That was the bad poke. Okay, so I don't think this is the right way to build our pointer. Right. Why would you be able to, right? Because a pointer is an address, the value, so kind of has to come from the C side for... How do we make this work then? We can't pass this on the stack, which is why we need to pass the shim as a pointer. I can't call the FFI unless I can make these pointers somehow. And I don't want to make a pointer word 128 on the C side, because that's a Haskell value. I just want to allocate one of these, get a pointer to it, and be able to pass that pointer into here. Let's look at data wide words. Implementation of storable. Poke. Hey, TwitchD. Yeah. We're trying to wrap some C libraries here to make our Tigerbeetle client. So that's what they provide for people to create the language wrappers in other languages. So on and so forth. So yeah, slow going, but you know, it's coming along. Storable. Okay. I'm not developing Tigerbeetle, at least not yet. I'm just writing a Haskell client in order to like learn a little bit about it and how it works. And because like I use Haskell in general at work and stuff, so it seemed like something to play around with. Tigerbeetle's a financial transaction database. It's kind of specialized for doing financial transactions stuff. Tigerbeetle.com. This is the kind of stuff I build at work, but yeah, thought I'd check it out. The challenge that I'm having wrapping this API that they provide for foreign function clients is that they use GCC extensions for some of the types they use. So I'm learning a bit about Haskell's FFI and like how to pass user-defined values in Haskell and marshal them over to the C side and then pack those up into the call that we need to make. So this foreign import call works and compiles our C shim and calls our C shim. That's good at the moment. What I'm trying to do now is construct a pointer to a word 128 somehow so that I could pass it in on the Haskell side. Foreign.pointer doesn't expose the constructor pointers. Why would it? Yeah, so yeah, we have to construct it some other way. Yeah, the idea here is that we have this shim library that we're compiling into our Haskell code, and we're passing those in by pointers. So like this uint128t thing. I actually think I have to create like a type def for our own type. So we're gonna like define, let me get rid of this dumb stuff here. So this is our shim. And the idea under the hood is that this is gonna call the client code on the C side and using the Tigerbeetle's API. We're just going to dereference this argument here and like construct the uint128t type that they use and pass that in basically from the Haskell type. So I think that's probably the first step we need to really think about doing here is creating our struct for our unsigned int 128. Which is going to be award 64. Award 64T. High. And uint 64T low. That's what we'll get from the wide word library. So we might be able to marshal to that. And then change this. Oh, sorry, TwitchD. I wish I knew what was going on there. It was good seeing you. connection here. Dropping tons of frames. Awesome. Yeah, I don't know what's happening. Sorry, man. I hope this rebounds. That's super annoying. Okay, well, I gotta wrap up anyway. I'm running late here. So it's good seeing you, Twitch T. Sorry, everybody who's watching and this has got like super low frame rate. Okay, so yeah, actually, we should probably cut it off there. Anyways, yeah, I think we're gonna have to do an HS unit 128 here and handle the marshalling on the C side a little bit and figure out how to do this on the Haskell side and pass this through. So we'll do that next time we work on this project. For now, let's clean this up and see what we need to commit still. Yeah, we'll get rid of that code. Okay, we just need to rebase this. Kill that. I'm gonna kill my VM, restart it. Put it back up and all that stuff. And then we're gonna do that. And all right, well, I'm kind of glad that we got quite a bit of progress here. We got our foreign C code calling and all that stuff, and now we're figuring out how to marshal this 128-bit type thing, and it's working. Ish. We're getting there. And I could see a path forward to it. So I think the lesson learned here from Friday and today's stream is that code generation is super useful, but maybe only really use it when you know like what's happening under the hood. You know what it's generating and what to look for. So keep that in mind. Let's get this code up. All right, so this code lives up on github.com. Agent Ultra, that's me. And this has been Tigerbeetle HS, our Tigerbeetle database client written for Haskell using the foreign function interface. Skadoosh. And we're going to Tigerbeetle HS here. Okay, we're going to rebase here. Squash that. That's a light C shim around the Tigerbeetle API. The Marshall Haskell types. And pass by value API. This seems to be the approach. Okay, pushing up. There we go. So all the code you've seen tonight is up here on GitHub, Agent Ultra /Tigerbeetle.hs. I am, of course, Agent Ultra. I'm also Agent Ultra on the Fediverse, where you can follow me there to get updates on this stream and like just to see my posts about programming and other things and stuff like that. Also got links to my YouTube where I back up the thoughts for this stream. So if you're watching in a different time zone, or you want to go back and watch some of the stuff we've done before, you can go check out the YouTube channel there by checking out types.pl. I'm Agent Ultra on that server there. I do these streams once a week on Tuesday evenings, usually at 10 after 8 in the Eastern time zone. So if you're interested in following along, write that down. If you like getting notifications, give us a follow here on Twitch. Or if you're watching on YouTube and you're one of our YouTube friends, subscribe. like, and all that stuff. And you'll get notified when I post a new stream or a new video, that sort of thing. So thanks again for watching. May all your monads be free and your types always check. And we'll see you on the flip side. Happy hacking out there.